Hello, welcome everyone. Today is Tuesday, January 12th. Um, I'm here with Jan, right?
Yeah,
Um, a young upcoming force in the software development community. And I've noticed Jan on mostly on Twitter offering really high quality content and very consistently on a daily basis. So we started chatting and here we are today. We're going to talk about whatever Jan finds attractive and interesting in our profession. So, welcome, Jan. And please, if you don't mind, just tell us a little bit about yourself.
yeah, sure. So, as Alex said, my name is Jan. I'm coming from Slovenia, and yeah, I've been a software engineer for almost 6 years now. I've studied electrical engineering. I received a master's degree. So yeah, that's a bit about my profession. And when I'm not programming or doing business related things for a startup, Typeless, which I co-founded, I'm usually windsurfing or skiing, or running, playing squash, playing football, anything that increases my heart rate and that's competitive enough. Yeah, and I have two daughters. One is 4 and another one is 1, and the gorgeous wife. So yeah, that's the brief about me.
Thank you. And so, from electrical engineering, what drew you to start doing full-time software development?
Yeah, during my masters, I started working part time in a company which built enterprise software solutions. I I don't really remember how did I decide to send them a CV, but they invited me to interview, and yeah, they were pretty amazed with what we've discussed, and so they said, yeah, would you mind to come to work with us for part time or as much time as you're able to during your studies. And yeah, that's how I started. And then after 2 years, I left because we started Typeless, and yeah, I joined as a lead engineer, um, kind of CTO and everything everything else that needs to be done from CEO to business plans and interviewing, everything that needs to be done in such a small team.
Yeah, so maybe you can tell us a little bit more about your startup. What is it actually about?
Yeah, so we are developing a platform, a machine learning platform for document data extraction. So, for example, you can train a model for your invoices, and it extracts data automatically from it. So it can be scanned invoices or original PDF files. But it's not limited to invoices. It's basically done for any type of document. You start with blank models. You specify which fields do you want to extract, and then you can train it. What's the big difference between our solution and other similar solutions is that we are focused on automation. So we don't provide any general model. We don't use deep learning. We've built our machine learning library from scratch in pure Python, and you can automate your repeated documents basically fully. So you don't need to intervene at any point. But it's not that interesting right out of the box. So you need to do some labor yourself. but once you've automated a part of your documents, it's automated because we don't have a drift problems and other deep learning related problems. So yeah, once model is done, and it works. So yeah, and during that development, I've encountered a lot of challenges, because I always wanted to be as productive as possible, because we are a small team. So four guys need to do work for 40. And yeah, I'm always searching for new approaches, new ideas, how to improve our workflows. And I must say that in last year, I really managed to do a step up, because we've automated our testing deployments. We've gained a lot when we started using property-based testing for our machine learning library. This was a huge step, since we've stabilized it with property-based tests. It hasn't been changed for the last 6 months. So yeah, that's maybe the something about iPlus from development perspective. And I'm also very proud, because in 2020 I had a goal to come to a point where green pipeline means we go to production, no questions asked. And I've managed to do that in November, after 6 months of struggles and and a lot of hard work. Now we are at the point where we deploy even 15 times a day. So basically every change goes straight to production.
Wow, that's amazing. You don't see that often.
Yeah, we don't see that often. In the company that I worked as my first real job, I must say that they had a lot of things figured out, but still they were doing Scrum, and there were sprints for 2 weeks, and then we have reviews and acceptance tests and God knows what, and it took a month to deliver some feature to production usually. But now we are at the point that it's maybe a couple of hours. So yeah, I've optimized pipeline on a GitLab with our own runner to go from 15 minutes from push to production to go to 4 minutes and a half.
And do you feel there's still room for improvement, or did you hit the wall?
No, there is a lot of room for improvement. Just today, I did a pair session with my colleague, and he asked me, "Hey, where are tests for this command?" And I said, "Oh gosh, they must be here somewhere, but I don't know. We must find them." So yeah, there is quite a lot of room to improvement. There are also some parts that they need to automate, and yeah, from terms of testing, on some parts of our code base, everything is as I want it to be, but on some parts I need to apply a bit more clean architecture approaches to simplify and speed up tests. So yeah, there's no fear to get out of space for improvement.
You feel you could still shave off some minutes or seconds from your deployment process?
Yeah, maybe I can improve it for maybe 10 to 20%, but I've cached basically all that can be cached, so dependencies are not installed in a pipeline if there were no changes in them. If the log file is the same, it just ignore everything and use dependencies as they are. Yeah, maybe the now the longest time is a time to bring job to the life. So Yeah, but I'm not sure if I can do any better here, because it's basically done by GitLab runners. So yeah.
Gotcha. Okay. So in your product, is everything homegrown, or do you use some third-party commodities as part of it?
Yeah, we are using third-party OCR, so we didn't develop that ourselves. We focused our development on only on data indexation, so on the machine learning part. So yeah, we use third-party services. We use Google Vision API to extract from AWS, and yeah, we host everything on AWS cloud. But I try to be as cloud as agnostic as possible, but it's not possible for all the cases. So there are some parts that are tied to AWS. For example, we are using DynamoDB, and I can't spin up DynamoDB in Azure or Google Cloud Platform, but I try to keep these parts separate enough that I can switch that to Postgres or anything else if I need to.
Okay, so this is like software as service, right? You're selling.
Yeah. It's a REST API which is built for developers. So it's not end product for business people, but it's for developers to integrate this part into ERP systems, document management systems, expense management trackers, and stuff like that.
Great. Okay, so is that primarily why you are mostly using Python, because of machine learning, or some other reasons?
Yeah, one reason is that we are using it because of machine learning. We started with deep learning, with TensorFlow and scikit-learn, but then we moved to to our own implementations. And another reason is that I used Python before a lot, so I used it during my university programs for machine learning applications, and I also used it for numerical mathematics. So when we started, I didn't want to learn a new language because it solved our problems at the time, and it still does a great job for us. So I like the simplicity of Python. I like the fact that you don't need to do much to create a readable and maintainable code base. But yeah, it always comes with trade-offs. At some points, I wish I was forced to use types because yeah, at some points, you, especially if your team is not mature enough, you can come to some stupid bugs just because of type mismatched and stuff like this. But yeah, so far I don't see a need to switch to another language, but I could easily do all the work that is done in Python. We could do it in Java or Go or anything else, because it's not tied to any specific language features.
Okay, and yeah, Python is a very popular language, so
Yeah, it's easy to find the developers, but like with every other language, is hard to find developers that produce some high quality products.
Yeah, and speaking of which, from what I gather from your tweets, I think you were also quite familiar with test-driven development, right?
Yeah, sure. I've struggled with it a lot. I'd say that it's been in last 3 months that I would say that I'm really starting to getting it. Discussions with you helped me a lot, because before I didn't have anyone who would think like me, in terms of development workflow. So yeah, I'd say it took me more than 3 years to really get it, because it's completely different from the test-driven examples with simple functions or methods that that sums to numbers, and then when it comes to your business problems and the problems that you are maybe not even really aware how big they are until you started the work. That there is huge gap between the test-driven development from the majority of resources and that I found, and between applying it for real in your day-to-day development.
Mm-hmm. So what do you find like the biggest challenge or obstacle when you're trying to do TDD in your scenarios or use cases?
One big challenge was to where to start, what should be the unit. That was maybe one of the biggest issues. How to split parts into testable chunks that can collaborate together to bring a value, and how to write tests that are not tied to the implementation. So how to really focus on interface and behavior instead of underlying code, which does what it does.
So I'm trying to remember. Python doesn't have like formal interfaces, right? That you can do.
No. Python don't have formal interfaces. You can define them by using abstract base class library. So you can define abstract methods, and if you define only abstract methods, that's basically interface. But it uses duck typing, so as long as your interface is the same, it works.
I see. So you find that that's not a impediment to your TDD practice, that you cannot focus on interfaces.
I think that it requires a bit more maturity than a formal interfaces. For example, in Java, because you are forced to use them, and in Python you basically can write anything and it will run eventually. So yeah, it requires more discipline and more mature developer to do it right. But now I'd say I don't see any major drawbacks from this.
No, that's great. That's encouraging to hear, because most of the hands-on teaching with TDD pretty much revolves around interfaces, right? So
yeah, sure. I'm when I'm reading books or articles or whatever, many of them, or maybe most of them, about test-driven development are in C# or in Java, but I don't really mind because I know how to transfer that in Python. It's basically much easier to implement something like this in Python. The only difference is that there is no formal structure that would force you to do that, but I can write 3 classes which has all the same interface, and I can inject them anywhere. I can call them with the same parameters, and it will work. But yeah, on the other hand, because I don't have a formal interface, I can also write stupid methods that are just a bit different, just enough different that I won't be able to, for example, to do dependency injection, because at third class the method requires one more parameter.
And do you do any meta programming in Python?
No, I haven't did any meta programming, so I try to stay away from all things that seems too magical. If I don't have a use case that would really require such things, And yeah, I talked with some guys about metaprogramming, and some are really big fans, but I've saw a lot of things built in Python. I saw people trying to mimic Java-like environments, so to force subclassing and such checks. But when you take another look on this, you see that if you need to force everything, you're doing something wrong. If you need to be aware which instance is that class A or class B, you have a problem in your software design. So you shouldn't care about the type of your instances, as long as they have the same interface. And I try to follow that idea when I'm writing code. And yeah, sometimes it goes well, sometimes I fuck it up, but
Sure. Yeah, I didn't mean to, drive this just to discuss about Python, but I was curious what made you choose it. But one thing I want to ask you, and I hope we can use your electrical engineering background as a comparison. And maybe this something that you don't notice or haven't noticed, but I'm noticing a lot as I'm teaching, I'm leading teams, and I'm introducing new concepts and old concepts that look like they're new ones. But and interestingly, one thing I find really interesting is I'm meeting a lot of resistance when I'm trying to introduce many teams to the concept of virtualization. That in our profession and in engineering in general, we build things by simulating. Whether it's hardware or I'm assuming electrical engineering or any other, there's a lot of simulation, a lot of pretending that something is there that really isn't there, and we see that everywhere. Like you have pilots being trained in flight simulators, simulating some extreme scenarios where the plane is about to crash, and all these things that you really cannot do in a real plane with real passengers on board. And all that is, I think, completely normal for anyone who has engineering background. But for some reason, I'm meeting a lot of software developers who completely disagree with simulation and insist that everything has to be tested with real, tangible. If you have an API, it has to be a real API. If you have a component, it has to be a real component. And they really push back and resist this practice of let's pretend it's there. And then we can just fake it.
Yeah.
And we can continue, writing code and building and testing, even though the thing that we are depending on is not really there. And I'm curious to hear whether you have any experience with that, or what would be your take on that.
Yeah, I'd say I'm seeing the same thing a lot. I remember from my college. Yeah, in electrical engineering, you are forced to simulate chips. You are forced to simulate dependencies between transistors, because you simply cannot afford to build it every time that that you want to change something and try something new. So I think that one major problem that we have in software is that it's so easy to change. And if you take a look at the electrical engineering, for example, electrical socket in our houses haven't changed for decades. And no one tries to really change it, because it would require to change installations in all the houses, and it would be simply too expensive to do it. So when you are building something new, you need to embrace that interface and then build on the top of it. You cannot say I need 15 pins to run my vacuum cleaner. You only can have 3 of them, and that's it. And I think that many of this resistance in teams is because in software we don't, too many times we don't really mind between about contracts between teams and systems. So if we say that the interface will be like that, oh yeah, and we will add another attribute, and we will add another thing to the body, and oh, it's a required parameter, and we crashed half of our system. Oh yeah, we will do a revert. So I think that this is the problem, that that we simply don't trust that the thing that's not there for real will really be the same as we expect when we will plug it in.
Okay. This is despite the fact that we've, as industry, have, I believe, pretty much embraced the principle of semantic versioning, right?
Yeah.
Most teams do version, and they do oblige that there's like some kind of a contract where I'm pretty sure your API has semantic versioning, and that if I'm going to be using your service, I'm going to be clear which version am I hitting, right?
Yeah, sure. There may be changes, but these changes for sure won't be breakable. So
Yeah,
you
but
will have everything that you depend on will be on the same spot every time that you hit it.
and that's the definition of semantic versioning, that
Yeah.
you always know what you're dealing with. Is it deleterious change, or is it just a minor, minor patch, or is it like a major, or whatever? So interestingly, what you say is, in other engineering industries, we do not have that kind of trepidation, but in software we do, which really is kind of surprising, right? But why? What's different? And second thing I'm curious about is when you say software is so easy to change, because I cannot tell you how many times I hit situation where like this has to change. I'm like, oh no, this is going to take 6 months. Software is super hard to change. Most projects you enter and you start working, you're like, yo, don't even look in that direction. This is going to be such a risky thing to even touch. So software is extremely brittle, and people are very, very afraid of change, right? So I'm curious where is this your sentiment software is easy to change coming from? Because the experience out in the field is the opposite.
Yeah, I didn't mean to change it into another working version, but for example, if you want to do a change on your CPU unit, you need to open your computer, you need to take it out, you would need to hit it hard to destroy it, or to do something with it. You can't really open the CPU unit and patch something differently, although it may not work. But in software, you can simply, I don't know, you change the dependency version and you break everything, and it can be only one character change in your source
I
code.
misunderstood you, because what you meant. So now, of course, it's easily breakable. Yeah, that's no. Excellent, awesome, thank you. I totally misunderstood you. Sorry.
Yeah. So yeah, on the other hand, to do changes which you've described, that's a whole another story.
Yeah. There's a huge resistance to any change because it's so easy to break.
Yeah,
and
it's easy to break.
Mm-hmm.
It's easy to break because we many times we don't really know what we are doing. We just want to use duct tape and some sticks and build a skyscraper.
Yeah, exactly. Yeah. That's
if you take a look on development of chips, you'll see that they announce some new version for. I think I spoke with one guy who is working on development for antennas for mobile phones. They announced a new version for 2016. It was out in September last year. So there was 4-year delay because they were simply not able to deliver a working version. And it's because it's so expensive to do that in large quantities. You need to be really sure that what you've built is working properly. And in software, it's many times put it to production, we will see what happened. And then maybe we won't sleep for a weekend, and then we will hate our employer. And yeah, and the story goes on, and then we will release another version in 6 months, which will change basically everything that we have at this moment.
So it's still software sounds like, from what you're saying, quite immature software industry, and like GOP in the US, no consequences. Whatever you do, like they just let's move on.
Yeah. There's a bug. Yeah, who cares?
Let's move on.
Yeah, it's yeah, it's a bug. The issue on GitHub is open, so who cares?
That's my pet peeve is when I talk to a lot of software professionals, and they have this sentiment, which is fairly prevailing, which when we just go shrug and say bugs are inevitable, and I have a problem with that, because like, that's a defeatist approach. Like no matter what you do, you're gonna have lots of bugs, and so get used to it and move on. And I'm thinking, well, that's not very professional, but I wouldn't hire a person who tells me, look, bugs are inevitable, so what you gonna do? Nothing. That is not very promising, right? For their work ethics.
Yeah, of course. I agree that they're inevitable, but it's there is a huge difference if you make this an excuse to do a sloppy work, or you try to minimize them, although you know that there is always a chance that something will slip between your fingers. But if you at least try to catch everything that you're able to do, it's I think that the quality of software will be much different. So it's not okay if you use the facts for excuse to not do something in a proper way.
It's like if you're planning to get married and you look at stats and you realize that domestic violence is rampant, and I'll just say, look, I know I'm going to be beating you every now and then, but it's inevitable. We're gonna come to blows. I wouldn't go into that marriage, right? So because look, man, sooner or later I'm going to start beating you up. But that's whole life.
That statistic says that.
I'm not even going to try to avoid domestic violence. It's like it's going to happen sooner or later. So make peace with that. Let's move on.
Yeah.
And that's the sentiment I often see in software. Look, dude, it's going to blow, right? It's going to blow up, and get used to it. I'm like, I'm not going to get used to
it. me neither.
Yeah. So, right. Basically, in your short experience with TDD, have you noticed any improvement in like, or got a sense of like maybe it's helping you author less bugs?
Yeah, sure. I've seen that a lot. Although I'd say that the biggest difference was when we shortened our development cycles. So when we started to really do small things, like maybe at most half of day, so maybe 4 hours of work. And when we started pairing, because I must say that the most of the time I have 1,000 things in my head, and it's so easy to miss some angle of the problem, or to miss something that should be asserted in test, but you just simply don't remember to do that. And when you have another person by your side, at least for me, usually the things that I miss, the other person catches, and hey, you've wrote the same value twice here. We forgot to assert that I don't know, that this must always be greater than 0, and it may be the very important part of the problem. So yeah, I've seen a lot of improvements in our workflow and in my also in my head. I've started to be less nervous about the deployments. So if 1 year ago a deployment was really stressful for me every time, so I'd say it was 9 out of 10, but now maybe 3 out of 10, but I want to bring it to 1 out of 10. So to be as dull job as possible.
So on that note, have you tried mutation testing?
No, I haven't tried it so far, but I've listened to your discussion with I forgot his name, the guy for mutation testing.
Oh yeah,
I think he's
Marcus.
from Germany. Yeah. I've listened to your discussion, and yeah, that's something I added to my wish list. Maybe one problem that I see is that I think that the only library that's available for Python is not that mature.
Yeah.
Although I think it has around 500 stars on GitHub, so it should be at least for enough for trying to do that. And yeah, that's certainly something I want to try, but I want to master TDD without it first. So yeah, I think I'll try it maybe in second half of this year.
The reason I'm asking is when you mentioned when you're doing pair programming that it's easier to catch some of the things that you might have missed on. And mutation testing often feels like somebody sitting next to you and telling you, oh, what about this? Right. And it's automated, right? So it's a cheap way, non-intrusive way for you to get a second opinion on what you're doing. And then you say, oh, of course.
Yeah.
When somebody points out, like, oh yeah, of course, like that. It's so obvious, but like you say, in the heat of the battle, you are following your train of thought, and there's some things surrounding that may you're rushing. You just don't stop and look around. Mutation testing often points out these things to you, and yes, some of those are quite trivial, but still.
Yeah.
I find it really helps people tighten the screws on the code.
Yeah.
And so it costs nothing. And yeah, depending on like Marcus, he's a genius. He really honed his mutant. It's a fantastic tool. Not every language is fortunate to have that. And Marcus, he could build like something for Python or C#, but he needs financial incentive and the open source that don't work that way, right? But like if you were doing Ruby and if you're taking his mutant, that would be fantastic because it's in real time, right? It's telling you in real time. From like I'm also doing C# and it's more batch, and so I'm not happy with it because the feedback is delayed. But still, better than not having any feedback, right?
Indeed.
So that's something I would kind of be curious when you try if you see that if it makes difference or not. But I'm pretty sure it's gonna help you a little bit.
Yeah, sure. I've seen a similar thing when we started with property-based testing, because it forces you to think completely different. And for our use cases, especially in the machine learning part, it's a really great tool because it really forces you to think about edge cases like really small numbers, float point arithmetic, and stuff like that, which you wouldn't think about with normal unit test. So yeah, it's also completely different mindset. you basically need to find something that's true for the whole range of your inputs. So
Yeah.
either some inversion function or some other attribute that must be true all the time. So it's a lot like mathematical functions.
Yeah. Yeah. So speaking of which, since you have formal education, master's degree, and you're doing Python, are you leaning more towards object-oriented or functional, or any mix of those two? Imperative.
Yeah, I'm leaning towards object-oriented.
Object-oriented. Okay.
Yeah. I really like the clean architecture idea from Uncle Bob. So lately I'm trying to implement it in our code base. And yeah, last week I just finished this rework on one of our services, which is quite small, so it was perfect to do something new. And yeah, I must say that so far I'm really impressed with what I managed to do. Because yeah, now it's really simple to extend it without touching anything. There is everything is based on interfaces. I try to really follow all of the solid principles, and yeah, so far I think that's the way, that's the most natural to me. To
Have you looked at Alistair Coburn's hexagonal architecture?
Yeah, I've looked at it a while ago, but I must admit that at the time I didn't really imagine how to do that. But now more and more, I think that I'm leaning somewhere in that direction, because I really try to keep my web frameworks away from my business as much as possible. We are running most of our services on AWS Lambdas with Flask, and I have a Flask in a single file where each of the views has basically maybe 1 or 2 lines, because it only executes use cases and returns the results. So yeah, I would try to separate the business logic out of my web framework, because then there is also messages from SQS that are processed, and they invokes the same use cases as a request from the web API. So yeah, I try to build things in that way.
That sounds close to the ports and adapters and
Yeah.
Because it really. I mean, the idea is to maximize deterministic side of your app. Where you can,
sure.
You can you can isolate deterministic processing that always gives you predictable results from the imperative shell, which is very, very hard to test.
Yeah,
more challenging to test. But the more you tease out your processing logic out of that hard to test layer into your core thing that does not depend on any configuration or any environment. You want to avoid the situation where people say, "Yeah, but it works on my computer." No, okay.
yeah. That we've talked about things to improve in Typeless, and yeah, one of them is one test suite is too dependent on database. So if you don't have installed everything on your computer, half of the tests are failing. So yeah, that's one of the things that I have a plan to improve in next month or two, because I hate that. I want to be able to run tests on any computer without anything else. That okay, maybe 4 or 5 tests that are just integration toward database, but all the unit tests must test on any computer without
Right.
additional work.
Even going back to those integration tests, and again, this is where I'm finding a lot of resistance, is all these things could be simulated, right? And then your environment independent. And like you said, I think the major maybe anxiety is that we don't trust the dependency.
Yeah.
Right. Which means, or oftentimes I'm finding, like if you have two different teams and one team depends on the services of another team, and then they take their API or whatever it is, and they kind of, okay, we can leverage this, and our code will depend on this, and we get some services and some processing. And then when I tell them, why don't you simulate that? Why do you have to, because if you're hitting the real environment, it's very hard to test some edge cases, like what happens when the clock goes from December 31st to January 1st,
Yeah.
Because they want to see what, there's all these situations that are kind of hard to test if you're touching the real thing. Therefore, you simulate, and then you can go berserk. You can just change everything and see how your code behaves on extreme situations. And they don't want to do that. And then when I poke a bit further, it's because the original team who is supplying the services, they don't really know how their services work.
Yeah.
They cannot really describe to you. This is what happens when you send us this. They have built something, like you say, with duct tape and some sticks. And they're like, look, we know that it's pretty likely if you send us this, we're going to send you that, but we really don't know.
Yeah. Yeah, software engineering is too many times stitching and patching.
Yeah, and nobody really knows how the thing works.
Yeah.
It works. Okay, so we have, I think, less than 10 minutes. Do you have anything to ask me, or you want to just chat?
Yeah. How do you decide which practices to try, and at which moments? So when you encounter something new, like you talked about test, commit, revert. So how do you try that in your day-to-day workflow to get some feedback, to see if that works for your use cases and for your approach to work?
So are you asking, how do I decide to even try it, or once I decide to try it, how do I go about trying it?
Both. So what's the main reason that you decide to try something, and how do you incorporate that into your day-to-day workflow to get some feedback and to not overload your work with something new?
Gotcha. Okay. So my general kind of approach is, I feel like whatever we're doing right now, it's pretty bad. Like I don't think we are mature at all. I think we're in diapers. So I'm very critical, and I'm not happy with the way we're doing things. I think there's much better ways to do it. I don't know what those ways are, but I know there's got to be a better way, right? And so I'm very open. I'm very keen on sniffing around and poking and looking at people who are introducing some severe constraints, or something that when you read is like, oh my God, this is so stupid. I'm really interested in these things. I'm not interested in following something that regurgitating, or something that everybody's talking about. I think that's bullshit, and I'm not buying it, right? So I'm always on the lookout people who are very radical. I like radical things. Something like makes you stop dead in your tracks. Like, oh my God, like what is this guy smoking? This is just like, so for example, I hear about TCR. I'm like, okay, this is really out of the left field. Like, why would any idiot do that, right? And right there, I know there's something to it, because it has to be extreme. Right? The same as with extreme programming. Like when I was young, and first time I heard extreme programming, like, oh, this is the stupidest thing ever, right? But my curiosity, I'm like, okay, there's got to be something to it, right? And indeed, back then, it went. You can't even imagine how radical that felt, and how much against the grain it was. Like, no, these guys are some renegades, some pirates, orbit the Capitol building and they're burning everything. It's completely counterintuitive. And why would any normal person ever even think about it, right? So I'm the same today. I'm just looking for these outrageous claims, and then I follow, and then okay, I'm not foolishly jumping in and drop everything you're doing and spend month, but I always give it a try. I try and find some time, be it on the weekend, after hours, or whenever I can grab some time, and I'm gonna do, because I believe in evidence. I don't like I do like some authority. Like for example, for me, Kent Beck is an authority. So when Kent Beck speaks, I listen. I'm like, okay, and I may not agree with him, but I'm like, okay, I'm paying attention. A few other guys, I'm always like, okay, because I know there's a chance that maybe they will 9 out of 10 they will have some bullshit, but that's one gem in the 10%. And so yeah, of course, Kent Beck, he says like we need symmetry. He says I like symmetry. So if you are doing TDD and you're making changes to your code base and you're reluctant to commit because your code is half baked, but the moment you get to your green bar and the moment your tests pass, then you're like, okay, why don't I commit? It says, okay, why don't we introduce symmetry? Why don't we reset, hard reset when it fails? I'm like, okay, this is the stupidest thing ever. This is just like totally counterproductive, right? And then I go and I try, and all of a sudden I'm like, oh, I like it. I really like it. You try it for size. You try it for your own feel, right? How it works for you. And now I love it. I like doing it. And really, I can give you an analogy. A friend of mine, and don't try this at home, right? But when, let's say you have your tooth is rotten or something, right? And you have a toothache. You go to the dentist, and they will drill and remove the whatever. And of course, the dentist, they're going to freeze your mouth, right? So you don't feel nothing, and they can. But this guy refuses any anesthetics. And I'm like, are you crazy? He says, you know why? Because now he's super cautious when he's working. He freezes my mouth. You can just go and like totally destroy my tooth and all that. He says, but now, because I'm going to be screaming, and TCR feels like that. Okay, now that you are, know that you are doing stuff and all of a sudden it just poof disappears in front of your eyes, all of a sudden I'm much more alert, right? And so I like that, right? But it's not for everyone, right?
Yeah, sure. And how do you have any pattern or something like that to encourage someone in your team who is not that in love with TDD and projects like that to really embrace it? Because I think we most of us struggle with that, because there is always at least one guy in a team who is, no, I don't want to write test first. That's stupid. Yeah, how should I know how the test would look like if I don't know what should I build? And yeah, you're just wasting your time. You don't need that simple code, simple change. Why should I waste my time with tests?
Yeah, we have. There is a percentage of, I don't know what the percentage is, but the percentage of developers who are adamant that any time spent writing tests is much better spent writing code. So these people are fairly adamant. Some of them are militantly adamant. My only argument is to somehow, one way or another, because I'm running TDD dojos where we are like in the same room. We used to be in the same room. Now we're in the same Zoom chat. My strongest argument is to say, okay, so here you are, you're writing code. And then somebody asks you like, no, spend some time writing tests. And you're like, wow, this is stupid because time writing tests is taken, this time is taken away from me from writing code and I'm paid to write code. Okay, that math adds up. I'm buying that. But if I look at two teams, one is doing TDD, the other one is doing just coding. Don't just look at the time they spend coding. Look at everything they're doing. They are, okay, they're making some code changes. Now they have to go and manually start the app. Now they have to configure for this specific environment and whatnot. They have to do a lot of pedestrian work. Now they have to navigate to the area in the app where they may change. Now they have to manually add some test data. And that time, when you add it up, is phenomenally larger than the time you spend writing tests first. So this is my strongest argument. To say this is false math to claim that teams who are not doing TDD are faster. They're not. Plus, I'm observing that teams that are not doing TDD are doing a lot of debugging. Because now they fire up the debugger, they're stepping through the code, and it's very pedestrian, and this is, all that is unproductive time. And if I am the guy who is investing and I'm paying I'm signing the paycheck, I would refuse to pay for that time. And she said, okay, I'm not paying you for your debugging session. I'm not paying you for your manual configuration, manual testing. That's not what you're hired for, right? I'm not paying for that. I mean, I would be an asshole if I did that, but hypothetically, you understand where I'm coming from.
Yeah, sure.
On the other hand, TDD guys, and I need to be symmetrical, I need to be fair, I would also say to TDD guys, I'm not paying you for writing tests. I'm only paying you for writing shipping code. And that's fair, right? And that's what I keep in mind when I'm on a paid project, that the time I spend writing tests are not billable time, right? But those tests should be really dead easy to write, a few minutes max, right? So I'm not really harming my paycheck or my invoice, my timesheet. And B, they save me all the time, because I look at teams that are doing TDD, barely ever they fire up a debugger, right? Because they're going in tiny little micro steps and everything is passing. So what is the point where you need to debug anything? It's very, very rarely you get to the point and say, okay, wait a minute, I need to spend half a day debugging and figure out what the hell is going on here. I don't understand why am I getting wrong results, right? And also, it precludes this problem with, well, it works on my computer. Because if you do TDD properly, it works on any computer. It doesn't matter where, right? Because it's completely independent of any environmental variables, right? Not to mention the regression suite of tests that not to mention you don't have to do any manual testing, don't have to retype any data over and over again. Everything is 100% automated, and you know exactly if your code base works 100% as expected or not. Plus, add to that mutation testing, and now you're really tightening the screws by saying no more fat finger mistakes. And if you are now asked to go, but when you look at, in my world, how do we earn our money? We earn our money by giving the business the flexibility to roll with the punches and to keep changing their policy rules. Because business runs on policy rules. And there's truckload of, especially large organizations, there's millions of these policy rules. And they're not like set in stone and forever. They keep changing, and the business keeps covering new opportunities. All of a sudden, rules change in a terrible function. IT teams, they're like, oh, no, we can't touch that. Everything blows up. So it's debilitating. So now you paint yourself into a corner when you depend on these things. You would like to change your policy rules, but they're telling you it's not advisable to touch that shit. So you're like, okay, so like this is supposed to be automation, and I'm so okay. How long will it take? Well, at least 6 months. By that time, the ship has sailed. The business lost the opportunity. So there's a lot of businesses very, very disappointed in information services and software, because it's just telling you, look, get used to it. No more changes. They go over to some ERP like PeopleSoft or the same story. Like, you need to transform your business to fit our model, not the other way around. Well, that's right. And so at the end of the day, all it boils down to how much flexibility can you offer to the business so they can turn on a dime. I want to get to the point when the business calls me and says, Alex, things have changed. We got COVID on that, blah, blah, blah. I can change it in a matter of minutes. And like you say, in 4 hours, you see it up and running. That's flexibility, right? Without risk.
Yeah.
I'm not jeopardizing anything. The worst thing is when you implement something and in the process you broke 15 other things that used to work, right?
Yeah.
So you want to get, that's where TDD helps in this whole philosophy where you can keep embracing change. Like, yeah, bring it on, no problem. And you're doing it and you're not breaking anything that already works. And so that's why we are keen, what you are doing, this is fantastic. The frequency of deployment is the key element here.
Yeah, sure.
You can deploy the better, you give more flexibility to the business, right? This is the key. And talk about extreme and radical things. I'm now interested in getting to the position where I deploy every keystroke. Every keystroke is live, right? So there's no more pipelines and blah, blah, blah. And, you know, because eventually software will get to that point where everything you're doing is already up there deployed. But that's for another topic, for another discussion.
Yeah, sure.
So, yeah, anything else?
Yeah. Do we have a time for one more question?
Yeah, absolutely.
So, how do you approach your code base when there is a change in existing business rule? Do you write a new class, new method with new test, or do you edit the existing one and change your code to make the new test pass?
Well, like you mentioned, we try to follow the solid principles, right? Which is open-close principle. And a class should be open for extension, but closed for change, right? So the code that we don't modify existing code, we extend, right?
Okay.
Separation of single responsibility principle, that they should have only one reason to change, etc. So all these things are very useful crutches and reminders and what's the word? Road signs on your journey.
Yeah, sure.
Okay. Look at your class. Is this really a single responsibility principle, or is it taking care of more than one thing at the same time, right?
Yeah, sure. No, but I was thinking, for example, if you would calculate some discount and the factor would change from 5 to 5.5, just like that. So it's the same business rule for same process, just one parameter has changed. Okay, maybe that's not really a good example, because you could have this parameterized and you would just edit that on call, but still. So yeah, I know if it's a new business rule, I will write a new code. So I will because I don't want to change existing one. If I want to extend existing one, I will extend it. I don't want to modify existing one. But what if business changes the existing rule as it is, and it's just slight variation of the one that's already there?
Well, that's something that I often see in daily practice, where people think that TDD is one shot. So you take, you do it one shot, and then when you hit the maintenance phase, then you forget about TDD, and now you're going back to your and so I see people, okay, doing TDD, first draft of everything's TDD, fine. All the policy rules are there. Then a rule, something changes, either it's the value or something. Then they just go in and they make changes in the code, and then tests break. I'm like, that's not how it works. It should always go from the expectation, which is coming from the business, and then it should never go straight to code. You must modify the test first.
Okay.
Right. So a proper sequence. If I need to embrace change and I'm saying, oh, okay, now, so the rule has changed. Now we're not applying 10% discount, we are applying 5% discount. I don't go to code and make the change. I go to the test, modify the test. The expectation has changed.
Okay.
Now the test fails, right? Because I changed the expectation. Now it's in red. Now I go and turn it green. Right. However, I feel like doing it and refactoring and whatnot.
Yeah, sure.
But it always has to go through that sequence. I see people jump straight into the code.
Yeah. Yeah, I did that a lot, but I must say that in last year I gained a lot of discipline there. So also when the changes come, I first added my test and then the code.
Yeah, it's like upstream. There are upstream things from us and downstream, but you got to respect. We're getting paid by taking initiative from upstream. Somebody's coming to us and telling us, "Oh, look, this now has changed." And, before TDD, code was the only source of truth, but now, like I know when I was going to some interviews, I tweeted recently, and they gave me a piece of paper with some code on it. It's okay, so the interview was for me to lead some team, to educate. So how would you review this? Do the code review? I'm like, where are the tests? I'm like, we don't write tests. I'm like, this is the end of discussion here. They were like, oh, what do you mean? I'm like, are you kidding me? This is 21st century. You're not writing tests. Like, what is it?
What do you do then?
So just like first learn, adopt some normal practices, and we can talk, right? I can't help you here, right? If you're not ready for that and you think test is stupid, I cannot help you. No way that I can do a code review that makes any sense to you, right? But to some people it's still like, oh wow, this guy is so arrogant. Oh, who do you think you are, right? But I'm like, move on with the program. This is 21st century. You can't live in the Stone Age.
Yeah, sure.
And again, I'm really happy that you are bringing your engineering discipline that I believe is much more mature from some other branches. Software is kind of Wild West, still shooting from the hip and duct tape. Yeah, sure.
Sure. Why not?
Why not? Yeah. Just toss it over the fence, see what happens. No consequences. Yeah, another thing I'm noticing, I mean, okay, this may be just my observation. On many projects or teams, there is this zero tolerance for rework, right? Like, rework, not acceptable. And yet there is unlimited tolerance for retries. So you're not allowed to rework or to revisit your first draft. You just like, no, ship it. And then it blows up, then they go back and say, okay, this blew up, but can you please try again? I'm like, guys, this is false math. You think you're wasting time if you let people do the rework, and yet you don't see the waste of time and money and reputation when you ask them to do retries. I would have zero policy for retries, right? But unlimited policy for rework. Like if you come to me and tell me, okay, I'm refactoring like crazy, I would, yes, I like it. I would not be saying, why are you changing the code that you already changed? Like, I already paid you to do it in the first place. I'm not paying you to do it again, right? That's what we are hearing from managers. Like, no, you already. But they see software as assembly line. So if you're working on assembly line, you have finished this component. Why are you now bringing it back again to work on it again, right?
Yeah.
But this is not assembly line, right?
Yeah, sure.
So that's where we are at the moment. Any other things you want to discuss?
No, I think
we're good.
I don't have any.
Great.
Anymore.
Thank you very much for this chat.
Yeah, thank you too.
Yeah, hope to see you again.
Yeah, sure. Anytime.
Maybe when you try mutation testing or something, you can update us on your experiences.
Yeah, sure.
It would be interesting to hear.
Yeah.
Okay, Jan. We'll chat later. Thank you.
Yeah, bye.
Bye. So, stop.